Okay, so this is really the last day of compound annual growth rates, so dealing with principal amounts um, and ending amounts. So we've got a do now here. It says Mr. McGinnis received a graduation gift of $30,000 in the stock of Facebook from Mr. Laux. Facebook stock produced an annual growth rate of 22%, and Mr. Laux bought the stock 10 years ago. How much did Mr. Laux buy Facebook for initially? So remember, our original formula gives us the amount after a certain period of time. The amount after a certain period of time is equal to our principal times 1 plus r to the t. Okay. So in this example, what I notice is that it's looking for the initial amount. That's actually what P is. So if we were to solve for P, we did this in a previous lesson, we're just dividing both sides by this term right here. So P, our beginning amount, is equal to A divided by 1 plus R to the T. And so here we've got an ending amount. Let's give myself a little more space. Ending amount was $30,000. Remember, I'm trying to find my principal amount, my beginning amount, my initial amount. So it's $30,000 divided by 1 plus, remember this 22% is 0.22, and I've got 10 years. So 1 plus 0.22 raised to the 10th power. And then if we go into our calculator here, we've got 30,000. Is this going to work for me? 30, apparently it's not. It's kind of a bummer. What's going on here? Oh, there we go. 30,000 divided by the quantity 1.22 to the 10th power, and we get 4,000. If I round that to the nearest dollar, hopefully you got the same on your calculator, 4,107. So let's write that in here. We get 4,107. So notice, again, it was 10 years ago, so it got to grow for 10 years, but this was my initial amount, and it grew to this over the course of 10 years at 22% a year. Okay, so in this lesson, I'm just going to go through a couple of other examples, and then the homework is actually at the end of this lesson. It should be pretty quick. It's just you doing 2 problems of your own. So there's only 4 slides. This is slide number 2, and I tried to make it a little bit relevant to what's going on currently. So we've got, due to the novel virus, students and teachers start using Zoom video conferencing. Maybe you guys have been doing some Zoom conferencing. Maybe you've even done one with me. A couple of CRJ students believe this will be a great stock to own. So they pool together $5,000 and buy some Zoom shares. If Zoom shares return 20% per year, how much will, can I do that? No, well, sorry, typo. How much will, real-time errors, how much will the students have after 20 years? So what I notice here in my question, the key phrase is after 20 years. This tells me I should look at my ending amount. So I want this formula because I know my initial amount, I know the return, I know the time, and I'm looking for my ending amount. After 20 years tells me I'm trying to find that. As opposed to initially, right? How much was it initially there? I'm trying to find this. So I use that formula. Okay, so amount equals my principal amount, 5,000, times 1 plus 0.2, not 0.02. 20% is going to be 0.20. So that goes here for R, and I held it for 20 years. So let's go to our calculator here. Clear this out. We've got 5,000 times 1.2 to the 10. Was it 10 or was it 20? No, I forget. I'm sorry, it was 20. Well, there you have it for 10. Let's hold that in mind. So 5,000 times 1.2 to the 20. And we get, holy cow, 191,688, 191,688. Based just on an initial investment of 5,000, obviously 20% in 20 years is, really shows you the power of compounding. What I did here is just a different question down here, kind of question number 2 here. What if Zoom only returns 10% per year? Then how much will the students have after 20 years? Again, after 20 years, I'm still using the same formula. I'm just changing my 20% to 10%. So amount equals still my initial amount of 5,000 times 1 plus, now it's just 0.10, right? 10% as a decimal equals 0.10 equals. Still for 20 years. Okay? And if we go to our calculator for that, we have 5,000, times 1.1 to the 20. And it gets us 33,000, we round to the nearest dollar, 33,638. 33,638. Don't forget our units. So we can see, and you still make, relative to our initial amount, a lot, but look at the power of compounding 20% versus just 10%. Right? So that again shows you the power of compounding at a higher rate. Okay, third slide. A different problem. Due to the novel virus, we've got some former CRJ students working for a company called Gilead to find a cure. They believe this will be a great investment going forward, so they decide to invest $10,000 in Gilead. How much will their investment be worth if Gilead shares grow 15% a year for 20 years? So again, 15% for 20 years tells me I'm going to need this formula. It always helps to write it out. And I also see down here, what if it's just 5%? So I'm going to be doing this one twice. Again, you could hit pause if you need at any time. My initial amount, 10,000. So my ending amount is my initial amount, 10,000, times 1 plus, remember, 15%. 15% is 0.15 as a decimal, so 1 plus 0.15 to the 20 power because I've got 20 years. So our calculator, we've got, what was it again? 10,000 times 1.15 to the 20. We've got 163,665. 163,665. 163,665. And the second one, again, if you look back, again, just looking at our previous one, we had 5,000 at 20%. Got us to 191. Here, 10,000 at 15% gives us an amount that's still less than the previous problem. So again, ironing home or hopefully hammering home that point of this, whatever your return is, and if you can compound it, you can get, you can really grow your investment. The second question down here is what if it only grows for 5%? Remember, this is not 0.5. This is 0.05 as a decimal. So now we've got still our initial 10,000 times 1 plus 0.05 to the 20. So let's do that on the calculator. And again, I would encourage you to try this on your own calculator or go to Google. I just Googled, you can see up here, calculator.
and I get 1.05. I'm hitting the caret up, but you can also hit this to get 20. And we get 26,533 if we 26,533. So notice my time was the same, right? But this 15% versus just 5%, this is still a good return over the course of 20 years. But look at the difference between these two, right? So the power of compounding at a higher rate is pretty powerful. Okay, so lastly, this is going to be your homework. Your homework is to create 2 problems of your own. Problem number 1, create a problem where you solve for the ending amount, A, right? And problem number 2, problem where you solve for the beginning amount, P. Remember the formulas. Ending amount, A, equals my beginning amount times a growth factor raised to a power. And my initial amount is my ending amount divided by that growth rate raised to a power. So give that a shot. Be creative. Maybe there's companies that you think are interesting or businesses that you think are interesting. Be creative. And try different values. Try different time periods. Try different growth rates. Try different values. Experiment a little. We're only asking you to do 2 problems, so hopefully that seems reasonable. And that is it for today.